Imagine a machine so powerful it could launch itself into the void, travel hundreds of millions of miles across the solar system, land on another world, refuel and return home, all without leaving behind a single piece of trash or burning a drop of fossil fuel. That's not just science fiction anymore. Because right now, Elon Musk and SpaceX are doing something extraordinary. They're not just building rockets. They're building the future. A future where Mars is within reach. Where humans walk on another planet. Where Earth is no longer our only home. Welcome to Starship's next chapter. In today's episode, we're diving into the most significant leap forward in SpaceX's history. A bold redesign, a powerful new engine, and a manufacturing revolution on a scale the world has never seen. Elon Musk has officially revealed how Starship is evolving physically, mechanically, and philosophically to meet humanity's greatest challenge yet, becoming an interplanetary species. But before Starship can fly to Mars, it needs to master Earth. SpaceX has always been clear about one thing: the rocket is just part of the story. The true magic, the secret sauce behind their audacity, is in manufacturing. Because sending one rocket to space is impressive. Sending hundreds, even thousands? That's how you change the future. That's why, in a dusty corner of southern Texas, right along the Gulf Coast, SpaceX has carved out something radical. A place with its own laws, its own identity, and perhaps soon, its own destiny. A city built by and for spaceflight, Starbase. This is where the journey begins. Starbase isn't just a launch site. It's a sprawling canvas of ambition, a blend of rocket graveyard and robotic birthplace, of science fiction turned metal and flame. Towering stacks of stainless steel loom above the salt flats like ancient totems of an era not yet written. And at the heart of it all, like the beating core of a mechanical organism, stands the Star Factory, a 1 million square foot production facility churning out pieces of the future like clockwork. But that's not the end of the expansion. SpaceX is now building something even bigger, the Gigab Bay. Musk says it will be one of the largest buildings in the world. He didn't say in what category: volume, footprint, production throughput, but it doesn't matter. What matters is what it will do. According to Elon, this assembly site could eventually produce up to 1,000 Starship upper stages per year. That's not just production, that's replication. That's scaling humanity's presence in space like never before. Inside this cathedral of metal and fire, starships won't just be built, they'll be born. Glistening in polished silver, segment by segment, these vessels will come together like spacefaring leviathans preparing to breach Earth's gravity well. And alongside them, the boosters, the mighty super heavies, will rise. Though fewer in number, they are essential, acting as the enormous first stage that propels Starship past Earth's atmosphere before returning back home. And that return is getting an upgrade. Reusability has always been SpaceX's North Star. But a rocket isn't reusable if it breaks. And the first few Starship launches, though revolutionary, were not smooth. SpaceX had to rethink some key pieces. One of the biggest changes came from how the upper stage separates from the booster. Originally, Starship used what's called a cold stage separation, where engines are shut off, and then the two stages gently detach. It worked in theory. But during its 2023 flight, the system proved too weak, too unpredictable, and ultimately too dangerous. So SpaceX made a bold move: hot staging. It's a brutal, dramatic technique. Instead of shutting off the booster engines first, the upper stage ignites its own engines while still attached. Flames roar directly onto the booster as Starship punches forward. The transition is faster, more forceful, and much more dangerous. To survive this firestorm, the booster needed armor. That's where the hot stage ring comes in. This wasn't just a patch. It was an entire redesign of the booster's upper segment. SpaceX inserted a new steel collar between the booster and the ship. Lined with vent ports and a heat shield, this ring acts as a shock absorber and blast deflector. It funnels superheated gas away from critical structures. It protects fuel tanks from melting. It's the difference between catastrophic failure and clean separation. But that early version was only temporary. A stopgap. Now, SpaceX has unveiled its permanent solution. During a recent presentation, Elon Musk stood on stage beside a towering structure that looked more like an art piece than rocket tech. It was angular, symmetrical, almost alien in design. But it wasn't new. In fact, it was inspired by something half a century old: the Soviet Union's ill-fated N-1 rocket. Back in the 1960s, the Soviets tried to reach the moon with a giant multi-stage rocket that, while flawed, carried some clever ideas. Chief among them was the use of a conical interstage segment that allowed flame to pass cleanly during hot staging. SpaceX took that forgotten design and perfected it. The new structure is wider, stronger, and cleaner than anything before. And it's not just about looks. The redesign allows for even larger fuel tanks to be packed into the booster. More fuel means longer burns, more payload, and crucially, support for the biggest upgrade yet. Meet the Raptor 3. At first glance, it doesn't even look like a rocket engine. There are no hoses, no wires, no exposed plumbing. It's smooth, symmetrical, eerily pristine. Musk calls it alien technology. And for once he might not be exaggerating. The Raptor 3 is a complete overhaul of SpaceX's main propulsion system. It's more powerful, more efficient, and astonishingly clean in design. But don't let that minimalist look fool you. Inside, the engine is a masterpiece of engineering. It operates on a full-flow staged combustion cycle, a rare and highly complex method that burns both fuel and oxidizer at extreme pressure to achieve unmatched performance. It's a system so difficult that no other rocket company has flown it successfully at scale. SpaceX is not only flying it, they're mass-producing it. In a test video released by SpaceX, the Raptor 3 roars to life with a violet blaze. There are no protective covers, no shielding around the engine bell. Why? Because it doesn't need them. By eliminating external hoses and wires, SpaceX has removed the very things that usually require shielding. That saves weight. And in rocketry, every gram matters. Less shielding means more room for payload. It also reduces the risk of onboard explosions. That's been a major sticking point in the past. On several test flights, Starships have suffered catastrophic failures when residual fuel or oxygen became trapped and ignited. The Raptor 3's open design minimizes that risk. It's safer, smarter, and built for scale. And it brings SpaceX one step closer to solving its next great challenge: re-entry. Because building a rocket that flies up is easy. It's coming back down that gets tricky. Starship must survive a fiery plunge through Earth's atmosphere at over 25 times the speed of sound. That means enduring temperatures hot enough to vaporize steel. And so far, that's where most test vehicles have failed. Tiles get ripped off. Surfaces crack. Heat seeps in. Even the smallest flaw can doom a mission. Elon Musk has made it clear. This is the final boss. Until Starship can re-enter reliably, again and again, there's no Mars. No moon. No future. And yet, the pieces are coming together. A more efficient booster. A better separation system. A cleaner, safer engine. A production line built to churn out ships by the thousand. This is not the end. This is the beginning. Because if all of this works, and SpaceX has a track record of making the impossible look routine, then we're not just looking at the next launch. We're looking at the next step in a planetary journey. One that will send people farther than ever before. One that will rewrite the story of humanity in real time. There's a moment in every great endeavor where the true test arrives. Not in a dramatic launch or a triumphant landing, but in the quiet, unseen war against physics itself. For SpaceX, that moment is now, and its battlefield is a thin black tile, the heat shield. Because without it, Starship burns. Without it, Mars remains a fantasy. This is the single most critical hurdle that stands between Earth and another home among the stars. And it's not just about surviving a return to Earth. It's about surviving the arrival on Mars. That, ironically, is even harder. Most people assume that Mars, with its whisper-thin atmosphere, would be easier on a spacecraft. There's less air, so surely there's less friction, right? Less heat? In reality, it's quite the opposite. The Martian atmosphere may be thin, less than 1% of Earth's surface pressure. But what is there is mostly carbon dioxide, a molecule that carries a dark twist. When Starship slams into the upper reaches of the Martian sky at tens of thousands of kilometers per hour, the friction compresses the gas into a glowing sheath of plasma, white-hot, searing, and volatile. And in that moment, the carbon dioxide breaks apart. The oxygen atoms go free. They don't float gently. They burn. They combine. They ignite. The result is a chemical storm of oxygen-fed plasma that violently eats away at anything in its path. That includes Starship's ceramic tiles. This problem isn't new to aerospace engineers, but it is now being tackled at a scale no one has dared attempt before. Unlike previous spacecraft, which used ablative shielding meant for one-time use, SpaceX wants Starship to return again and again, without melting, without crumbling, without failure. That means the heat shield can't just work once. It has to survive dozens of hellish re-entries across multiple planets. Elon Musk has described it as an extraordinarily difficult engineering puzzle. And yet, he remains, as always, boldly optimistic. He believes the puzzle will be solved in just a few years. Maybe even sooner. Musk claims the upgraded Starship, now outfitted with the simplified and powerful Raptor 3 engines and the re-engineered hot stage assembly, will be flight-ready by the end of this year. That's an aggressive timeline by any standard. But then again, aggressive is kind of the whole point. And the target is as audacious as the technology itself. A first launch window to Mars opening in 2026. That doesn't mean astronauts strapping in and waving goodbye just yet. The 2026 mission is about proving the system. It's about doing what's never been done before, sending a fully reusable spacecraft to another planet, aiming to land it softly on untested soil. The goal isn't glory, it's data. SpaceX plans to launch 5 Starships toward Mars, each one lightly loaded with just 10 metric tons of cargo. Not because they couldn't carry more, but because lighter ships need less fuel. And less fuel means fewer in-orbit refueling transfers, a mission bottleneck still being worked out. If all goes to plan, each of these ships might only need 1 or 2 refueling operations before heading out. Compare that to the 10 or more needed for a fully loaded interplanetary journey, and suddenly, these early voyages start to look not just possible but practical. But the success criteria here aren't measured in perfection. They're measured in probability. SpaceX expects most of these first landers to crash. And that's okay. This isn't about sticking the landing. It's about learning. If even one of these starships makes it down safely, touches Martian soil and sends back data, then the mission is a success. A new chapter begins. And with that proof, the next steps fall into place. 2 years later, Mars launch windows only open roughly every 26 months. SpaceX plans to scale up. In 2028, a second wave of 20 starships will lift off. Each will now carry 75 tons of cargo, a massive increase. By then, reusability, landing precision, and heat shielding should be far more reliable. The Martian surface will no longer be alien. It will be mapped. No, visited. These ships will carry machines, infrastructure components, and robots. Not humans. Not yet. They'll carry Tesla Optimus robots, autonomous humanoid machines that Elon Musk claims will serve as the first workers on Mars. It sounds like science fiction, but prototypes already exist. These bots will unload cargo, assemble shelters, connect power systems, and prepare the landing sites for future arrivals. Because in 2030, the scale increases again. 100 starships. 100 interplanetary flights. All aimed at Mars. Each vessel will carry 150 tons of payload this time. Equipment for mining. Tools for refining resources. Modular habitats, communication arrays, solar power units, water extraction systems. All the foundations of something bigger than a camp or an outpost. The early bones of a city. And those Tesla robots? They'll be doing more than just lifting crates. They'll be building roads, landing pads, even rudimentary structures. Everything must be prepared before the first human being ever sets foot on Martian soil. Because once people arrive, the clock starts ticking. Life support must work. Shelter must be airtight. Resources must be local. You can't rely on Earth when help is 55 million kilometers away. 500 starships. Each one capable of delivering 300 tons of cargo. That's 150,000 tons in a single interplanetary fleet. And that's just the beginning. These ships won't just be transporting gear. They'll be bringing independence. Resource extraction on Mars is no longer theoretical at this stage. Using the abundant CO2 in the atmosphere and water ice from beneath the soil, SpaceX aims to generate methane and oxygen, the very propellants needed for return journeys. It's a closed loop, an off-world supply chain, the beginnings of an economic system not tied to Earth. Starlink satellites, deployed into Martian orbit, will beam down global internet coverage. Rovers will crisscross the red plains delivering parts and information. Robots will work in shifts, building habitats, testing soil, extracting minerals. Massive solar arrays will come online, storing gigawatt-level power in underground vaults. The planet will awaken under the hiss of hydraulics and the hum of machinery. But none of it happens without scale. And scale means more rockets. By the mid-2030s, SpaceX intends to stretch Starship itself, literally. An upgraded frame, longer and stronger. A larger diameter. An engine cluster pushing up to 9 Raptors, including 6 vacuum-optimized bells capable of burning cleaner and longer in the silence of deep space. These stretched ships could ferry entire pressurized habitats, vehicles, laboratories, and even greenhouses in a single launch. The Mars city isn't a dream anymore. It's a construction site. The chosen location for all of this? The Arcadia Planitia, a broad, flat plain in Mars' northern hemisphere. There's a reason for the selection. It's smooth and safe to land. It's rich in water ice buried just under the regolith. And it's close enough to the equator for good solar exposure, but far enough north to access vast frozen resources. It's the Martian equivalent of a coastal port, a place where civilization can take root. But Musk has even bigger plans. He talks about an ultimate goal of 1000 to 2000 starships, all departing Earth over multiple launch windows. A flotilla of steel giants, carrying over 1 million tons of cargo to Mars. And even that might not be enough. Musk estimates it could take 10 million tons to truly build a self-sustaining city. Skyscrapers, factories, greenhouses, data centers. A place where people are born, live, and die, without ever needing Earth again. It sounds insane. But so did reusable rockets. So did landing boosters on ships in the middle of the ocean. Of course, it won't happen without cost. Hundreds of launch pads must be built across Earth. Massive fuel depots in orbit. Robotic construction teams. AI-managed life support systems. A lunar way station, maybe even asteroid resource harvesting. All of this will have to come together like clockwork. Then there's the elephant in the room, terraforming star. Musk has suggested, perhaps tongue-in-cheek, perhaps not, that we may one day warm the planet. Not with nuclear bombs, hopefully, that idea seems to have faded, but with industrial processes, greenhouse gases, and solar reflectors. It would take centuries, maybe millennia. But the seeds must be planted now. Because the goal isn't just to visit Mars. It's to live there. Forever. Some see it as hubris. Others as destiny. But love it or hate it, this is the plan. Not drawn up by science fiction writers but by engineers, machinists, and software coders. It's the blueprint of the most advanced private space company on Earth. And maybe, just maybe, it's our only shot. Because we've reached the edge of the map. Earth is fragile. And if we want our species to survive, our language, our ideas, our music and memories, then we have to reach farther.